Welcome to the homework solution tutorial on 1.c, average rate of change and reviewing the properties of the quadratic. Please notice that 1, 2, and 3 should have arrows on the ends of all the quadratic functions. Let's look at number 1. It asks us for the domain. The domain can be seen as your x values, and the x values on this coordinate grid exist on the horizontal axis, which is the x-axis. So we move our head from left to right. If we move our head left, we have this left arrow here. And then if we move to our right, we have the right arrow. This should help us find our domain. The domain on the left arrow goes all the way to negative infinity. Then if we move our head to the right, it goes all the way to positive infinity. So we can say that the domain exists because they're arrows, they go on forever, from negative infinity all the way to positive infinity. We can write this in interval notation with the parentheses on both ends because we cannot close down the infinities. The range can be seen as your y values. So you're looking bottom all the way to the top. If you look from the bottom, we can sort of zoom in here. This is around negative 6.5. So this number is slightly under it. So we can say, let's just give the point here. So the point here is roughly 0.5 comma negative 6.6. Okay, because if you look at down here, okay, that's half of that one. So that's that point there. Okay, but the y value here is negative 6.6. That is the lowest y value that this quadratic can take. So we write it right here, negative 6.6, and goes all the way up to positive infinity. Okay. We open it with a parentheses at the infinity on the right, but we have to close it with the bracket because it touches that negative 6.6 for the range. Let's look at the interval of increasing and decreasing. We notice if we follow like a person right here, okay, they're going down, they are decreasing here, and then they go back up here, so this will be increasing. So let's do the decreasing first. So notice it starts here from negative infinity. It decreases all the way until it hits what point? The x value of the vertex. So it goes all the way to 0.5. Okay, we keep it open here at negative infinity, and we keep it open here at 0.5. The reason why is because also at 0.5, that's when it starts increasing as well. You don't know if we are closing the 0.5 at the decreasing or the increasing part. So we keep it open for both. Okay, comma, and goes all the way to positive infinity. All right, please notice that for a quadratic, because it is very symmetrical, the location in which the interval flips from decreasing to increasing will always be at the vertex or the line of symmetry. Let's look at the interval of positive and interval of the negative. What they mean by positive really means when the function is greater than 0. That's the notation we use in class. And when they mean by negative is when the function is less than 0. So I always use that color orange here to denote it. So this is the line. Anything above it, this is when the function is greater than 0 or the output is greater than 0. And below here, this is when the function is less than 0. So let's take a look. So it starts decreasing. Let's see. So if you take a look, as you're going down here, notice this is still positive. Okay, this is still positive. And this is still positive. Okay, that point in which it's still positive, that it stops here, this is when x is equal to negative 1. And right here, this is when x is equal to 2. So the interval that it's still positive goes all the way from that negative infinity, goes all the way to that negative 1, and we keep it open. So this is the first part here. If you see the arrow, then the second one would be right here, this part. Okay, it would be from 2 comma all the way to positive infinity. And again, let me draw the arrows to denote that for you. There you go. That's when it's positive. Next, when is it negative? Let me use green here. Okay, so when the function here is less than 0, so it's negative, notice right here. Okay, so it's only negative at this interval here. All right. So that is -1 all the way to 2. Okay. And we keep that open here as well. Okay, so that's where it is negative. All right. Lastly, the rate of change from when x equals to -1 and when x equals to 1. The rate of change can be, it's very similar to the slope formula. You can write m for the slope, or we will write rate of change between 2 points, x1, y1, and x2, y2, can be seen in the format of the equation y2 minus y1 divided by x2 minus x1. So what we need here are the points. Okay, we have to grab it here. So notice when x is equal to -1, it's right here. It's this point. It would be -1 comma 0. That would be the first point. And the second point, when x is 1, it looks like it's this point here, which looks like 1 comma 6, -6. Okay, so the fact that you have those 2 points, your life is easier. Let me just write it. -1 comma 0, and the second point would be -1 comma 6. The reason why this is the first point is because it's the left side. We look at it from left to right. So this is the first point, and then it goes all the way here to the second point. Okay, so now we can plug it into the equation. y2 would be -6 minus a y1. Oh, actually, let's just make this easier. I'm just going to show it visually. So look, y2 replaces that, BC. Okay. Then we have y1 gets replaced by 0. Then we have x2, which is then -1, and we subtract that to x1, which is -1. Okay. When there's that negative, each time I make the substitution, I like to put a parentheses in it. All right, so there you go. Now we can just finish and work out the math. So -6 minus 0 would just be -6. -1 minus a negative, okay, that is the same thing as just adding. So this would be, hold on, am I mistaken here? Oh, sorry. This should be a +1. Hold on, -1. This should be, yeah, this should be a +1. Sorry about that. This should be a +1. So it's 1 minus -1. So this should be a 2. I had to check myself. It's like, there's no way this could be equal to 0. So it becomes -6 divided by 2. That is the same thing as -3 over 1. Or you can just write it as just -3. Okay, that is that rate of change from the first point to the second point. Okay, so the same thing that we're going to do with number 2. I'm going to walk you through it because now it's the quadratic is flipped. Okay, the domain is the same because notice this is the left arrow and there is a right arrow. So it does go from -infinity all the way to +infinity. Parentheses to keep it open. The range, again, now we start from the bottom all the way to the top. Notice we start from -infinity. And what's the highest value that it goes to? That looks like it's a 4.5. Okay, yeah, 4.5. And it does touch 4.5, so we close it with a bracket. parentheses to keep it open at the negative infinity. Let's look at the interval where it's increasing. Before we do that, let's get the vertex just in case here. So the vertex here is at what point? That looks like 1.5, comma, the y value here is 4.5. Right, this does help us because if we imagine our person here, it is increasing at this moment, and then it decreases here. So it is increasing from, look at it, negative infinity, all the way to our vertex point, which is 0.5 for the y. Sorry, 1.5 for the x. Okay, so we keep it open at both ends. Interval decreasing, it starts decreasing from what x value? That 1.5. And then it goes all the way to positive infinity. And we keep it open. Notice, right? These two have to be the same value, right? It's that line of symmetry. It is the x value of the vertex. Okay, that it starts flipping from increasing to decreasing. Interval of positive and negative. Let me clean this up a bit, okay? Hang on. Okay, that looks better. All right, the interval of where it's positive, I'm going to make that orange. This is when the output, where the function is greater than 0. So function is greater than 0. And I'm going to make that green now, where it's negative, where the function is less than 0. So down here, this is when the function is less than 0. Okay, so now we can start looking at the values in which that does occur. Now, notice that the function will start where? Below or above 0. Yep, you are right. It does start when it's negative. Okay, and it looks like it stops here at this point right here at 0, 0. Let's just label the x-intercepts to help us, 3, 0. So you are right. It starts decreasing here, and it also starts decreasing here. And we know that this is from negative infinity all the way to the point right here, 0 for the x value. So we can say it goes from negative infinity all the way to 0. We keep it open with the parentheses. Then also, oops, I forgot. When we have 2 points here, I forgot it's both of them. So we have to make sure we write that union symbol. Okay. Then also from 3 all the way to positive infinity as well. 3 all the way to positive infinity. And we keep it open. Because these are both of them, we have to include the union because it's both of these. All right. So those are the two intervals that it is negative. And then let's look at the interval that's positive. So it would be here. Right? See how these are all positive values? All right, let's see. So it looks like it goes from 0 all the way to 3. So it would be 3 all the way to 0. And we want to keep it both open. And then there you go. That's it. Lastly, let's find the rate of change. So again, let's just help us along by grabbing our formula from before. Okay, that's the rate of change formula. And we want to know the 2 points. The 2 points here is when x is equal to 1. So x is equal to 1. Looks like it's that point here. That looks like it's 1, 4. And then x equals to 3. Oh, we already have it. 3, 0. Okay. So the first point, let's just clean this up. The first point that we have is 1, 4. And then the second point that we have is 3, 0. The rate of change formula can be seen as y2 minus y1 divided by x2 minus x1. Okay. Make the substitution in. Y2 is 0 minus y1 is 4. Divide this by x2, which is 3, minus 1 for the x. 0 minus 4 is negative 4. 3 minus 1 is 2. We can simplify this to be 2 over 1, or you can say it is just negative 2 as well. So that is that rate of change from this point all the way to that point there. Okay. All right, so I'm not gonna do I'm not gonna do 3 in detail. I'm gonna give you the answer so you can double check it, because 3 is very similar to 1. Okay, so I'm not gonna give an explanation for that. I'm just gonna give you the answer. Then I'm going to show number 4. All right, there you go. That is the answers for number 3. The explanation again is very similar to number 1. Let's look at number 4. Let's find the rate of change between this. We know what is required for the rate of change formula here. We require 2 points. So what you need to do is grab the points. How do you get the graph or the points by this equation? Well, you can't graph it, but here I'm going to show you how to get it numerically. Okay, so this is your input. If you put in that value -4 in here, you're going to get an output of the y. So that's what we're going to do. Okay, so it's technically easier when you write it like this. Let me show you. Okay, so the function of x is equal to -x² minus 4x plus 6. So now you're going to substitute in, let's say, -4 for x. So notice it becomes negative. I'm just going to put a parentheses here. -4 squared minus 4 parentheses for that substitution plus 6. All right. So this should get me -4 squared is 16, and there's a negative front, so that's -16. So this is -4 times -4, so that's a positive 16 plus 6. Okay, and this should get you that value of 0, I believe. Let me double check here. Hold on. Yep. So this is 0 and that's 6. So this should get me 6. Good. So we can say that if we plug in that value in this function for x is -4, your output is 6. So that point would be -4 comma 6. This would be your first point. Okay. So let's do your second point. Same process, but now we're plugging in a 4 for that. So it's the same equation, but this time we plug in a 4. Let me make it blue so you could see the difference. So 4 squared minus 4 parentheses -4 and then plus 6. All right. So so we have 4 squared. That makes 16, and there's a negative in front, so it's -16. -4 times -4 is a positive 16, and then you want to add the 6 here. Give me 1 second to double check my negatives. Oh yes, you see, I made that substitution wrong. This is a positive. That's why it looked wrong. Okay. So this -4 times +4, this should be a. Let me clean this up correctly. That should be a -16. Perfect. So -16 plus -16 is -32 plus 6. That should get you, hold on, let me double check. Okay. And that gets you your -26. All right. So when we plug in that value of 4 in that function, we get an output of -26. So we can say that our second point is 4 comma -26. All right. Our life is easier because it is like before. Here is our equation for the rate of change. Rate of change. Here's our equation. All right. So now let me just make that substitution. So y2 was our -26 minus y1 is our 6 divided by x2, that is our 4, minus x1, which is our -4 here. -26 minus 6, that does get you our -32. 4 minus, oh, sorry, there should be a negative here. Minus -4 is a 8. Yeah, negative, yeah, positive, yeah. And this does simplify to getting you a -4/1, or you can just say that it's just -4. Okay, so there you go.